Welcome to Lecture 15, an Object Grabber Package. In this chapter, we're going to integrate manipulation with grasping. And as you'll see, it'll take considerable detail and depth to code both of these aspects together. For the very same reason, it's important to have maximum flexibility. Consider, if you spend much time preparing code that has a large number of files and many lines of code, it better be flexible so that it can be used in different scenarios. Otherwise, you'll undergo much pain in trying to use that code again. You want it to be reusable across different robots or different robotic arms, different grippers, or even different objects. So in order to achieve both flexibility and reusability, we always keep in mind the following concepts. Our code should be modular. Each program or process should do the least number of jobs, or one individual job. So if you have a process that's doing moving and grasping, it's always better to separate that such that one program is in charge of moving and another one is in charge of grasping. You want to encapsulate. That is, you don't want to show dependencies to the user, but just show in the interface one thing so that the programmers do not code in a way that compromises the independence and the flexibility of one node. It's important to be scalable. That is, that we can easily integrate additional pieces of code or nodes or programs into our architecture. So if you have different grasping techniques that you might implement for a robot, it would be important that your code allows for further integration of grasping techniques in a way that doesn't change your code. In 15.1, we're going to have an overview of the code organization. In this chapter, we have a hierarchical presentation for our sets of objects that we use for grasping and manipulation. Our hierarchy is going to be organized from a high level of abstraction to a low level of abstraction. That means at the very high level, we're not going to be concerned with the details of the robot or specific robot configurations. All we want to do is just focus on the task. In this chapter, we don't talk about vision, but ideally you would have a vision service sitting at the top that is looking at the environment, recognizing objects, and then telling you about the type of objects that you're working with along with their pose. Once you have that, you might have a client that is interested in performing the high-level commands for grasping an object. More specifically, this grabber client might have commands that say, hey, I want to approach the object that the vision service provided for me. The approach is a kind of pre-grasp location or trajectory to that location, preparing yourself for a grasp. And then grasp is the actual job of gripping the object at the right position and in the right way. And finally, the release of the object is moving it to another desirable location and placing or leaving as needed. So this grabber client, of course, will have this goal, and what it's going to do is pass the object type through an object ID. And this chapter, we're going to hard code that, but again, it could come from the vision service. It's also going to pass along the object pose, a frame of reference for the object of interest. And then it might also talk about the kind of grasp type that we want to do that can be grasp from the top or a grasp from the side, as we will introduce in a second. So this grabber client is part of the object grabber package, and we're going to be using the object grabber action message to define this interface. So here we have the object grabber package and then the object grabber.action file where you're going to run rust-ed on that. And you'll see that here at the bottom we have our goal, we have our result, and we have our feedback. Let me just point you towards the goal, which consists of a few fields. Number one, an action code. Number two, an object ID. And number three, a grasp option. This is basically all we're going to be using right here. Action codes are listed here, and though we have so many, we're mostly going to be using only a few. Number one, move to a waiting pose. So this is preparing to approach a surface, getting ready to do some kind of grasping. Then we also have the grab object. This is actually trying to grab the object and drop off the object. Place it on a surface. So these are the kind of action codes that we're going to be using. The object ID, as we're going to show you later, actually comes from a header file, not from here in terms of its encoding. And the last one is the manipulation strategy, or the grasp strategy. In this simple example, we just call something a default grasp strategy, which has, as we'll see in the code, for depending on the gripper, an approach from the side or an approach from the top. So when these commands get sent by the client and to the action server, this server, which is aware of the robot, whether we're using a Baxter or a UR10, this server is aware of that. It's also aware of the gripper that the particular robot is using. That is going to be set up through a launch file and setting some information in the ROS parameter server. And of course, it's going to get the object ID as well. So ultimately, the object grabber is going to be returning paths to reach the desired approach, and then it's going to do all the work for grasping the object and then also releasing the object. But in order to do that, we want to continue to be modular and encapsulated. So we're going to use two services. The first one is called the object manipulation query service. And so here what we do is we pass the object ID and the gripper ID. Let's take a look at that file. So this is part of the object manipulation properties package. And this is the service message. In the service message, we only have a request and a response. So here you can see the object ID and the gripper ID and the grasp option, some of which are similar from before. In this grasp option, you can see grasp from above or grasp from the side. Okay. And so this service actually is gonna, let me do one more thing in terms of talking about what we return in terms of the response. In terms of the response, we're gonna, number one, return grasp strategy options. So what can we do? Can we grab from the top or the side as a response? But also we're going to have these gripper pose options. And now this is an array of poses. Okay, so there may be different strategies here, and this is what is going to tell our hand where it should move. So this returns the gripper post options given the specific object and gripper type. Another service that we're using is called the generic gripper service, and this is just in charge of controlling the gripper. So here, if we have 2 fingers, this will be in charge of the interface for opening and closing. Or if we have a vacuum gripper, it would be in charge of sucking the air or releasing the air to grab the object. So this is how we modularize the tasks at the object grabber action server. Once we have the poses for the object grabber action server, however, we want to be able to move the robot. For this reason, we can use the Cartesian Planner Action Server that we introduced in the previous chapter to move to the desired location. So this is another action based on Cartesian, and this is what's going to do the planning and the execution together through a generic interface. Once the plan is executed, we use another action server, this time the trajectory action server, which we also visited earlier, and as a way to interpolate goals through waypoints and create very smooth trajectories. Finally, once we have all the waypoints in place, these are sent to the robot controller through a publication of a topic, and then the onboard controllers can actually actuate the motors. So you'll see that in section 15.2 we're introducing object manipulation query service, and 15.3 we're introducing the generic gripper service. In 15.4 we introduce the object grabber action server, and then in section 15.5 we introduce the grabber client that gets all of this going. And really the task here is just, I want to pick a toy object, a block from a table, so I'm going to approach, pick, and release.